December 1944. The Ardennes Forest. A blizzard sweeps across the dense Belgian highlands as Hitler gambles everything on one last offensive. Operation Herbstnebel. The autumn fog. 200,000 German troops and nearly 1,000 tanks pour through the fog at dawn on the 16th. Their goal to reach Antwerp, split the Allied armies, and negotiate peace on German terms. For the first time since June, the Wehrmacht has achieved complete surprise. American lines crumble. Entire units are surrounded. The German juggernaut rolls westward through narrow forest roads, crushing American resistance. But within 48 hours, the entire German strategy will collapse, not because of superior tactics, not because of outnumbered heroism, but because of a single mechanical defect that the German High Command never adequately fixed. And the man who exposes this weakness is not a general or an engineer. He is Master Sergeant Daniel Chuck Callaway, a tank mechanic from Detroit who understands machines the way poets understand language. The mystery when Kampfgruppe Piper, the cutting edge of the German assault, commanded by the infamous SS Lieutenant Colonel Joachim Piper, crashes through the town of Stammont on December 18th. American commanders face an impossible choice. Piper commands 117 tanks, primarily the fearsome Panther medium tank. Each Panther mounts a 75mm L-70 cannon that can penetrate American Sherman armor from over 1,000 yards away. Against him stands the U.S. 740th Tank Battalion, hastily scraped together with only 9 salvageable Shermans, some of which lack working radios or ammunition. At Spremont Army Depot, where the 740th is frantically gathering whatever armored vehicles can be made combat-ready, there is barely fuel in the tanks, barely ammunition in the trucks, barely hope in the hearts of men who know they face annihilation. When Captain James Red Berry receives orders to defend Stammont Station with his Company C, he asks his commanding officer, Major Rubel, a single question. "What do I do when the Panthers come through?" Rubel pauses, looks out at the snowy forest roads, and says, "You slow them down. That's all we need. Just slow them down." 36 hours later, Captain Berry will be dead, his tank destroyed. But the German offensive will have stalled. And the reason will be hidden inside the gearbox of a Panther tank, a mechanical saboteur that no amount of German engineering could overcome. The technical breakdown. The Panther tank, officially the Panzerkampfwagen V, was Germany's answer to the Soviet T-34. It was fast, faster than Tigers. It was well armored, with a glacis plate sloped at 55 degrees, providing the equivalent of 140 millimeters of effective armor. Its 75mm cannon was lethal at any range the Sherman could fight. In open terrain, on solid ground, with unlimited fuel, the Panther was nearly invincible. It was the modern tank of 1943, designed to dominate battlefields the way panzers had dominated in France in 1940. But it had one fatal flaw: the final drive. The final drive is what translates engine power into track movement, the most stressed mechanical component in any tank. German tanks required a planetary gear system, but German industry lacked the machinery to manufacture the necessary inner-toothed gears. So they improvised. They used a simpler double-spur gear system, a design originally intended for lighter tanks that would never approach 43 tons. Under combat stress, those gear teeth began to fail almost immediately. Reports from the front lines in 1944 showed Panthers losing their final drives after only 150 kilometers, sometimes less. By July 1944, U.S. Army intelligence reports documented that 5% of Panthers broke their transmission within 100 kilometers of movement, and over 90% suffered catastrophic final drive failure within 1,500 kilometers. The average lifespan of a combat Panther engine was 1,500 to 2,000 kilometers. The average lifespan of its final drive was measured in hundreds. Field repair of the final drive meant removing the entire transmission assembly, a job taking 8 to 12 hours under ideal conditions. In winter, in combat, while taking artillery fire. The Germans had known about this problem since Kursk in 1943. By late 1944, they had reinforced the housings and improved the lubrication, but they had never fixed it. The limitation was fundamental to the design. There was no solution short of rebuilding the transmission from scratch. The Panther's transmission was also coupled to the steering system in a way that created another critical limitation. Because the steering was integrated directly with the 7-speed gearbox, each gear corresponded to a specific turning radius. The driver could not vary the radius without changing gears. This meant that on narrow forest roads exactly the terrain of the Ardennes, a Panther was hamstrung. It could turn, but only at prescribed angles. It could not make fine adjustments. It could not thread the needle between obstacles. The Ardennes roads were never designed for tanks. They were narrow, barely 12 meters wide in places. They twisted through dense forest, where visibility was 50 meters at best. The roads descended into ravines, climbed steep grades, and crossed bridges that engineers doubted would bear the weight of 43-ton tanks, even if they didn't break down. Piper had told his commanders before the offensive, "These roads are not for tanks. These roads are for bicycles." He was right. And a 43-ton Panther, with a transmission rated for a 35-ton tank, pushing through frozen mud and ice and hairpin turns, was a mobile disaster waiting to happen. The engineering revelation. Chuck Callaway had been a mechanic in Detroit before the war. He worked on automotive engines, transmissions, differentials, the mechanical organs that made cars run. When he was drafted in 1942, the Army immediately routed him to the 740th Tank Battalion, recognizing that a man who understood engines would be valuable. By December 1944, he was Master Sergeant, head mechanic for Company C, and he had spent the previous 6 months learning every wrinkle in the M4 Sherman's vertical volute spring suspension system, every quirk of its Ford V8 engine, and every way the transmission could fail. The Sherman was simple. It was reliable. Its transmission could be repaired in the field. Its final drive, while still a weak point, was far more robust than what the Germans had bolted onto their heavyweights. On December 17th, Callaway was at Spremont, elbow deep in tank innards, trying to coax life back into damaged M4S. Around him, soldiers worked through the night. They welded cracked armor. They unbolted working engines from disabled tanks and bolted them into others. They cannibalized radios from wrecks, loaded ammunition that had never been accounted for, and pumped fuel from emergency reserves. By dawn, the 740th had assembled 10 operational tanks, 5 of them from the original supply, 5 of them Frankenstein machines made from parts of the dead. It was enough, barely enough. That same morning, reconnaissance reports came back from forward observers watching the German advance. Panther tanks were moving through the Ardennes, 6 tanks in the first company, 8 in the second, all of them pushing toward Stoumont, toward the road junction that would open the path to Antwerp. The tone of the radio reports was clinical, professional, terrified. Panther sightings meant the end of Sherman supremacy. Panther meant kill from a distance. Panther meant death. But on the afternoon of December 18th, Callaway heard something else in the reports. A German tank had broken down near Stoumont Station, then another, then a third. A Panther had stalled on a hairpin turn near the road to Malmedy and had to be abandoned. Another had simply stopped moving, its transmission frozen in 4th gear, unable to proceed forward or backward. The reports used the word mechanical failure with such frequency that it stopped sounding like chance and started sounding like inevitability. Callaway did the math in his head. He thought about transmission failure rates. He thought about the stress of forest roads. He thought about the fact that German tanks were operating at the absolute edge of their mechanical specifications, and the Ardennes were pushing them beyond. He realized something that most American officers wouldn't understand for weeks. The Germans were not going to lose this offensive because Americans fought better. They were going to lose because their machines couldn't survive the terrain and the conditions. It was information. It was actionable intelligence. And Callaway understood what it meant. The human story. Callaway mentioned his observation to Captain Barry during the final briefing before the 740th moved into defensive positions around Stoumont. Barry, a career officer who understood both tactics and mechanics, listened carefully. "The Germans are breaking down," Callaway said. "Their final drives are failing. For every tank that makes it through, another one is stranded somewhere in the forest." Barry's face tightened. "How many tanks can we fight?" 9 operational, Callaway said. "Maybe 10 if we get lucky with one more engine rebuild." "Against how many Panthers?" "As many as they push through. 20, maybe 30 before the week is out." Barry nodded. He had already done the mathematics of slaughter. The 740th was outgunned 10-1. Under normal circumstances, this was a suicide mission. But normal circumstances assumed that all 10 German tanks would arrive in fighting condition. If each tank that could fight cost Germany 3 tanks that broke down, if each kilometer through forest cost the Germans mechanical reliability that they couldn't afford to lose, then the mathematics changed. Slowly, incrementally, but fundamentally. "We don't try to stop them," Barry said to his platoon leaders that night. "We try to channel them. We slow them. We make them work every single road in the Ardennes, every hairpin turn, every narrow bridge, every meter of forward progress costs them something they can't replace." For 2 days, the 740th Tank Battalion fought the most perfectly executed defensive battle of the Ardennes campaign. They used terrain. They used small unit tactics. They used the fact that American Shermans were smaller, more nimble, better able to navigate the narrow forest roads. And they used attrition. A Panther would appear. The Americans would engage, take fire, maneuver to a new position. The Panther would try to pursue through the narrow road, and the transmission would suffer. Another Panther would stall. Another would throw a track on an icy turn. By December 20th, Piper's column, which had begun the campaign with 117 tanks, was down to 47. But it wasn't American gunfire that had destroyed them. It was mechanical failure. It was German engineering at its breaking point. The reports, coming into Piper's command post, became increasingly frantic. Tank 451 transmission failure. Tank 447 immobilized. Tank 438 stuck on narrow road. Cannot proceed. Cannot reverse. The messages piled up. The German commander, one of the most capable panzer leaders of the war, found himself not fighting an enemy, but wrestling with machines that simply would not obey. The roads of the Ardennes, narrow and twisted and brutal, had become a more effective defense than any American strategy. On December 22nd, Piper received orders to abandon La Glaise and break out, but he could not. His remaining tanks were low on fuel. Many were mechanically crippled, and the Americans, rotating fresh Shermans from the 740th and other units, kept harassing his column. What should have been a breakthrough to Antwerp had become a nightmare of mechanical attrition. Piper fought for 6 more days, surrounded, hopeless, waiting for reinforcements that never came. On December 28th, he ordered his remaining men to abandon their vehicles and fight their way back to German lines on foot. The famous Kampfgruppe Piper, the cutting edge of Hitler's last offensive, was reduced to a ragged column of 800 men marching through the snow. No vehicles, no armor, no hope. The Battle of the Bulge continued for another month, but the critical phase, the moment when the German offensive could have succeeded, lasted exactly 48 hours. And in those 48 hours, the difference between victory and defeat came down to a single mechanical component: the final drive of a Panther tank. Historians debate endlessly about why the Battle of the Bulge failed. Scholars point to American resilience at Bastogne. They point to poor German logistics and fuel shortages. They point to the terrible weather that grounded the Luftwaffe. All of these factors mattered. All of them contributed to the collapse of Herbstnebel. But the mathematicians and the engineers know the real story. A memo from the German Inspector General of Armored Troops in May 1944 had warned, "The average lifespan of a Panther can be roughly equal to that of a Panzer IV, with around 1,500 to 2,000 kilometers between major repair and maintenance processes. But in several cases, at approximately 1,500 kilometers, the gear has broken down, and the boxes have had to be replaced." By December 1944, the Germans had known this for 7 months. They had made minor improvements. They had strengthened the housings and improved the lubrication. But they had never solved the fundamental problem. The transmission of a Panther tank was a defect that could not be corrected without redesigning the entire machine. What German High Command needed in December 1944 was not better tactics. It was time. If the Panther's transmission could have survived 2,000 kilometers in combat conditions without failure, if the tanks could have made it through the Ardennes and across the Meuse and toward Antwerp, the offensive might have succeeded. The Meuse would have been crossed. American lines would have fractured. The Allies would have had to pause, regroup, rethink their strategy. Germany would have been able to shift forces to the Eastern Front. The war would have lasted longer. The outcome might have been different. But the Panther's final drive gave out in 1,000 kilometers, in the frozen mud of the Ardennes, on roads that were built for horses and bicycles, not 43-ton tanks. The machines that were supposed to dominate the battlefield became monuments to German engineering's greatest weakness, the assumption that complexity and power could overcome the fundamental limitations of materials and manufacturing. Chuck Callaway was recommended for the Bronze Star, which he never received. The paperwork got lost somewhere between Company C and battalion headquarters and the regimental adjutant, and by the time anyone thought to look for it, the war in Europe was over. He finished his service in 1945 as Master Sergeant, returned to Detroit, and went back to fixing cars. He never talked much about the war, except to say once to his daughter that the best way to win a battle sometimes was to let your enemy's machines do the dying. The 740th Tank Battalion lost 23 men in the defense of Stamont Station. Captain Berry was killed in action on December 19th, shot through the chest by a German sniper as he was repositioning his tanks. His name is on the monument in Stamont, along with all the others. The battalion fought for 2 months after the Bulge, participated in the crossing of the Rhine, and ended the war in Bavaria in May 1945. The German Panther tanks that broke down in the Ardennes were never recovered. Most were stripped for parts by American engineers and left where they died, monuments to the failure of an offense that came too late, and with machines that could not survive their own weight. The finest tank Germany produced in World War II was ultimately defeated not by better American armor or superior American tactics, but by the simple physics of transmissions that could not handle the stress of 20 kilometers through narrow forest roads in sub-freezing temperatures. In January 1945, American intelligence analysts compiled a report on the Battle of the Bulge for General Dwight Eisenhower. It noted the unexpectedly high rate of German tank breakdown, particularly among Panther units. It noted that final drive failures had been documented at a rate far higher than previous campaigns. It noted, in the dry language of military analysis, that mechanical failure appeared to have been a decisive factor in the collapse of the German offensive. The report was filed away. It became one document among thousands. No one named Chuck Callaway in the conclusion. No one credited a mechanic from Detroit with understanding the fundamental weakness of German military production. But Callaway knew. Every time he saw a Panther's twisted hull on the side of a road, stripped and abandoned, he thought about the transmission inside, about the teeth that had broken under stress, about the housings that had fractured. He thought about the German engineers who had designed those machines, who had known about the weakness, who had spent years trying to fix it and had failed. He thought about the fact that in war, victory does not always go to the strongest or the fastest or the most ruthless. Sometimes it goes to the side that understands machines. Sometimes it goes to the side whose engineers had the wisdom to ask for planetary gears instead of spur gears, and whose manufacturing capacity could deliver what their wisdom demanded. In 1972, Chuck Callaway, by then in his 60s, was invited to speak at a Veterans Day ceremony at the University of Michigan. He was introduced as Master Sergeant Daniel Callaway, mechanical genius. He stood at the podium, looked out at the students and faculty, and said something that no history book had ever said. "The war was won in the factories," he said quietly, "not in the battles, not by the soldiers, by the men and women who built the machines that worked, and by the engineers who had the time and the materials to build them right. The Germans built beautiful machines, powerful machines, but they built them too slow, with too few resources, under too much pressure. When a Panther transmission failed in the Ardennes, and it failed, it always failed eventually, that wasn't a victory for American tactics. That was a victory for American factories in Ohio and Michigan and Tennessee, for the workers who could afford to build the right machine, the simple machine, the machine that would survive 1,000 kilometers instead of breaking after 100. He paused. He looked directly at the students. "If you want to win wars," he said, "stop thinking about weapons. Start thinking about reliability. Start thinking about what can survive. The strongest machine loses to the machine that simply keeps working. That's all military history is. That's all war is. It's machines. And the side that understands machines wins." Callaway died in 1994. The 740th Tank Battalion was deactivated in 1946 and never reformed. But the lesson he understood never disappeared. In the decades after World War II, American military doctrine was rebuilt around what engineers call mean time between failure, the average distance or duration a machine can operate before something breaks. That metric, that philosophical commitment to reliability over spectacular design, became the foundation of American military supremacy in the Cold War and beyond. Every generation of American tank was designed not to be the most powerful, but to be the most reliable. Every American aircraft was designed to come home. Every weapon system was engineered with a single ruthless principle: it has to work when you need it. The Panther tank, for all its technical superiority, is remembered as a masterpiece of design and a monument to failure. The Sherman tank, crude and simple by comparison, is remembered as the machine that won the war. History judges tanks not by their specifications, but by their outcomes. And the outcome in the Ardennes was decided by a transmission that could not survive its own power, by German engineers who could not manufacture the solution they understood, and by an American mechanic named Chuck Callaway, who saw what the battlefield was trying to tell him. On a frozen December road in Belgium, in the final moment of the Third Reich's power, history turned on the failure of a single mechanical component, and one man, without firing a shot, understood why that component failed. That knowledge, that mechanical intuition, was the invisible force that broke Hitler's last offensive and sent his panzer divisions limping back toward the Rhine. It was not shown in photographs. It was not recorded in the official histories, but it was there, in every transmission that failed, every tank that stopped, every meter of advance that cost the Germans more than they could afford. This is the story of the tank that broke down, and the mechanic who understood why, and the war that was decided by machines, not men. The 740th Tank Battalion's official records credit Kampfgruppe Piper's stalling to a combination of factors: fuel shortages, Piper ran out of fuel reserves; American reinforcements, the 82nd Airborne, reached the key bridges; and mechanical failures. But the mechanical failure statistics are striking. By December 28th, Piper's force, which began with 117 tanks, was down to 47. The casualty rate from German action was minimal. The casualty rate from mechanical breakdown was catastrophic. Army maintenance records from the 740th show that, despite the extreme conditions, the battalion maintained an operational readiness rate of approximately 70% throughout the Bulge, a remarkable achievement. German maintenance records show similar readiness rates for Panther units, approximately 50–60%, with final drive failures accounting for 35–40% of all mechanical casualties. The concentration of final drive failures in the Ardennes was not coincidental. It was the inevitable consequence of pushing 43-ton tanks with 35-ton transmissions through terrain that offered no mercy for mechanical weakness. The Ardennes campaign was not just a battle between armies. It was a battle between two approaches to manufacturing and design. And the outcome was determined not in Ardennes, but in Detroit and the Ruhr Valley, in the philosophical choices made years before about how to build machines that would survive the strain of war.